Hi, this is Alex from devstories.eu. GitLab CI/CD episode 14 of 14. You try to define a job stage name using a standard CI variable, push your code, and immediately get a syntax error. The pipeline refuses to run. The problem is timing. The runner cannot define the pipeline structure using variables it only receives after the pipeline has already started. This is exactly where compile time CI expressions come in. Here is the key insight. Standard runtime variables, written with a single $sign, are evaluated by the shell when the job actually executes. By the time the runner sees them, the entire pipeline architecture is already locked. You cannot dynamically change a stage name, a service, or an image version during execution because GitLab needs that information up front to build the pipeline graph. Compile time expressions solve this by evaluating logic at the exact moment GitLab parses your YAML configuration, long before any runner is ever assigned. The syntax uses a $sign followed by double square brackets. Inside those brackets, you write an expression that evaluates to a value before the pipeline is created. These expressions draw their data from specific contexts. A context is essentially a restricted set of data available during YAML parsing. The most prominent context is the inputs context, which is heavily used when building CI/CD components. Take the scenario of a dynamic deployment component. You want the project consuming this component to pass an environment name as an input. You then want to use that input to set the job's stage name and dictate the specific Docker image version it pulls. Inside your component configuration, you write the stage field and assign it to a compile time expression containing inputs.environment. When a project includes your component, GitLab reads the provided environment input. It evaluates it immediately. The resulting pipeline graph sees a static, hard-coded stage name and a hard-coded image tag. The runner never encounters the double brackets. It simply receives standard configuration. Beyond inputs, compile time expressions also support a matrix context, which is currently in beta. When you generate parallel jobs using a keyword like parallel matrix, you can use compile time expressions to dynamically adjust job properties based on the specific variables assigned to each parallel instance. This prevents you from having to duplicate job definitions just to change one or two fields per matrix run. These expressions are more powerful than basic text replacement. You can write logic directly inside the brackets using equality operators as well as logical and or operators. You can evaluate whether an input matches a specific string and conditionally change a value based on the result. You also have access to built-in functions. The expand vars function, for example, allows you to safely inject compile time values into a string while explicitly preserving standard runtime variable syntax. This guarantees the runner still gets the runtime variables it expects without causing parsing conflicts early on. The critical takeaway is that compile time expressions give you a native mechanism to template your pipeline graph, cleanly separating structural generation logic from the actual script execution. Take some time to read through the official GitLab documentation, review the supported functions, and try deploying a component hands-on. If you have topics you would like to see covered in a future series, visit devstories.eu and let us know. Thanks for spending a few minutes with me. Until next time, take it easy.